Section 8.2, using the distributive property. Our essential question is, how do you use the distributive property to factor a polynomial? Our first vocab word is the distributive property, which you should remember because we've worked with a lot throughout the year. So the distributive property says that you distribute multiplication over addition or subtraction. So for example, if I have A times the sum of B plus C, that equals A times B plus A times C. So you distribute the multiplication over your addition. It's also true for subtraction. So if I distribute the multiplication over my subtraction, I would get AB minus AC. The second property that we have is called the zero product property, and this one is new. And we're going to use this one throughout Chapter 8. The zero product property says that if you multiply two things together, like A times B, you would get an answer of 0 if A or B equals 0. So I want you to think about this. So we're saying that the product of A and B equals 0 if one of those, or both of them, A or B, is equal to 0. So if A is 0, 0 times B equals 0, or if B is 0, A times 0 also equals 0. So when you're multiplying two things together, if one of those things happens to be 0, your product is going to be 0. That's called the zero product property. Okay, question number 1. Use the distributive property to factor the polynomial. Well, the distributive property, you think about the pieces in the distributive property. So I have a sum here. The distributive property involves having something out in front of the parentheses and then a couple of things inside the parentheses. Well, that piece that you see out in the front, that's your GCF, your greatest common factor. So that's why in the last section we were teaching you how to find the greatest common factor of monomials. So if you're good enough at finding the GCF now in this section, you won't have to do a factor tree. I know that the biggest number that I can divide into 27 and 18 is 9. It's 9. I know that 9 times 3 is 27, and 9 times 2 is 18. I also see that I have y to the second power and then y. So y to the second power means that I would have two y's multiplied together, but my second term has only one y. So in common, they only have one y in common. So I need that extra y after my 3. So I believe that my factored form is going to be 9y times 3y plus 2. That sum in parentheses. I'm going to show you with the factor tree so that in case you're looking at this and you're not as good at factoring as maybe some others are at this point, because you don't have to be able to do this without the factor tree. So 27 is 3 times 9, and 9 is 3 times 3. So factored form would be 3 times 3 times 3 times y. 18 is 2 times 9, which is 2 times 3 times 3, and I've got a y here. So my GCF, what they have in common, they have 2 3's and a y. So you notice that my GCF is correct. 3 times 3 times y is 9y. So I've got my GCF in front of the parentheses. So that's what you can pull out, the greatest common factor we're dividing out of each term. Now what's left in my parentheses, I have 3y plus 2. So the first one, I've got a 3y from here, 3 and a y. Second one, I've only got a 2 left over, 2. So if you use the factor tree way to pull out the GCF, what's left in each factor tree is what goes in your parentheses. That's what's left. Okay, my next one, I'm going to show you by doing the factor trees. So 5y to the third, well, 5 is prime, so it's just going to be 5 times 3y's. 10 is 2 times 5, and then I have y to the second, and 25 is 5 times 5, and just 1y. So what they have in common, they have a 5 and a y in common, so that's my GCF, 5y. Now what's left of each term? Y times y, so y squared, plus 2 times y, so 2y, minus 5. That's my factored form. So I've pulled out their greatest common factor. So 5, if you look at the coefficient numbers 5, 10, and 25, 5 is the greatest common factor of those numbers. And then the variable parts, the greatest common factor of the variables is just y, because that last term only had one y in it. So I couldn't take out more than 1. Okay, use the distributive property again. So, same thing. -1 times 4, 2 times 2, A times B, 2 times 4, times A, B squared, and then 2AB. Okay, so their GCF, what they have in common. I've got a 2, an A, and a B. So, 2AB. What's left? -1 times 2 is -2 times A, -2A. Minus 2 times 2 is 4 times B, 4B. Plus, nothing is left. So I need to put in the number 1 there, because think about this, if we're dividing out their greatest common factor, so I've taken out the 2, the A, and the B, well, I still need something to hold that place. So think about how when you distribute, you should get the original, you should get this original up here, polynomial. So 2AB times 1 is 2AB. So I've got to put a 1 there. So if you've removed all of the factors with your GCF, make sure you put in a 1 to hold that place. Okay, so the last one, I'm going to assume that we can go without the factor tree on this one. So the coefficient numbers are 7, 21, and -1. They do not have a factor in common. So the only thing I'm going to be able to do is take out variables that they have in common. This last term has one x and one y. Each of the other terms also have one x and one y, so I can take out x, y. The 7 stays, and I've taken out one x and one y. There's still one left of this term. I need my 21. I've taken out the x and one of the y's, so there's one left, and then the last term would just be -1. Because the x and y have been removed. If you ever want to check, you can always take your answer and distribute to make sure that you get that polynomial that you started with. Okay, now I'm going to teach you a different kind of factoring. This factoring is called factor by grouping. Factor by grouping. So what we're going to do is we're going to group together the first 2 terms and then the last 2 terms. And we're going to take their GCF out. So the first terms, I could divide out the 4 and a y. And that would leave me with x plus 2. My second set, I can only factor out a 3. That would leave me with x plus 2, because 3 times 2 is 6. So now what you should notice is that I've pulled out this common, I've pulled out their GCF, and it's left me with a common factor of x plus 2. So factoring by grouping, what was being multiplied by that x plus 2? First was 4y, and then was a 3. So I can write it as a binomial, 4y plus 3, because they were each being multiplied by x plus 2. That's factoring it by grouping. Let's do that again. Split. And this one's trickier because when I split these terms, I'm going to have to look at them with that minus. So here's what's tricky. If I put my parenthesis here around the x minus 5, remember that this minus would be distributed to the x and to the 5. So I'm actually going to have to change this sign to a plus to do that. Or I could change this to a plus and keep the minus or the negative on the x. Okay? So the first set of terms has a y in common, and that would leave me with the x plus the 5. So I need this next set to have a common factor of x plus 5, so I can see if I pull out the negative 1, that would work. So now I've got my factor of x plus 5, and then the other factor is going to be the y minus 1. Y minus 1. So this is kind of tricky, factoring by grouping. Remember, what you're trying to do is you're trying to get the same factor, the same binomial in your parentheses when you use that distributive property. So the two pieces that need to be the same, right here and right here. So I pulled out the 4y so that it left me with x plus 2. And I pulled out the 3, dividing it out, which left me with x plus 2. So on this next one, my first one, when I pulled out their common factor y, I had x plus 5 left. So I knew I needed the other one to be x plus 5, and it was very close. It was negative x minus 5. So I just had to take the negative 1 out, dividing each by negative 1, change them to positives. Two more that look like that so that we get some more practice. So this one is grouped, and this next one again, I'm going to make it a plus and negative and group it like that. So the first terms, I can take out just the x, and that will leave me with 2y plus 7. And then again, I can take out the negative 1, which will turn the 2y and 7 into positives. That's what I needed. Now, I've got my 2y plus 7 in common, and then I can take the x and the minus 1 to make my other binomial factor. Last one, grouping, and it's got a plus, so it's going to be easier on us. 15 and 3 can both be divided by 3, and I could take out an a. So I will have 5 left of this term, minus just the b, plus, on this one, if I take out a 4, it's not going to give me a negative on my b. If I take out a 4, it's going to give me b minus 5. So these aren't quite the same. So what I need to do instead is I need to take out the negative on one of them. So I'm going to take out the negative on the 3. So if I divide 15 by negative 3, I get negative 5. And if I divide out the negative and the 3, I get b. And that's exactly the same. So these, negative b plus 5 and b minus 5, are exactly the same. So I'm just going to go with the b minus 5. And then here I've got negative 3a plus 4 for my other factor. So that's 4 examples factoring by grouping.
6801, Joe Nordstrom 6801.
Okay, now last we're going to do the zero product property. Remember that we said if you multiply two things together and you get an answer of 0, one of the things you were multiplying has to equal 0 then. So if this one equals 0, What is x? If I subtract 5, x equals -5. What if this one equals 0? X minus 7 equals 0 instead. If I add 7, x equals 7. So these are the two options. Either x has to equal -5 or x equals 7, or both, in order to get a product of 0. Next one, same thing. If I set this one equal to 0, I add 2, x equals 2. If I set the other one equal to 0, I would add 1, and then I would divide by 4. So x equals 2, or 1/4. And then on the last one, if I set this equal to 0, 3x equals 0, well, 0 divided by 3 is 0. Or the other one, set it equal to 0, subtract 2, x equals -2. So, on each one of these, I can put my or in. Hopefully it makes sense. If the product equals 0, one of your factors, or both of them, had to equal 0. So just set them equal to 0 and solve it. Some of you can probably look at those and do that solving in your head. Could cover up one at a time and see what it would equal. And that's it for a lesson today. So you should be able to write a summary, and here are your homework problems. Be careful on the factor by grouping. Just make sure that you try everything out and ask for help if you need any help.